Read the question carefully. So here the balance at the beginning is 100,000 to be paid off in 30 years. That means with 360 payments, and the interest rate is 0.5% each month. Okay, so let A and B the balance of the mortgage after n month, then the initial balance. So A is 0, the balance after 0 month at the beginning, that's 100,000. Okay, and there is a 0.5% interest rate each month. So the balance after payment P, because we are monthly payment of P, the balance will be then AN plus 1. The balance in the next month is equal to the previous balance, which is AN, plus interest on this, that's 0.5, which is 0.005 of AN, and payment minus P. That's same as our AN plus 1 is equal to, we can add these two. So one copy 0.005, so 1.005 AN minus P. Okay, this is the model we are using here, and we want to find the monthly payment P. Okay, and we want P so that this balance is paid off after 360 payments, and want the balance after 360 payments, that's the A360, 0. Okay, now let's work on this to determine the value of P. If we take, because we know for A0, okay, we also know A360, so A sub 0, so if we take n equals 0, n equals 0 into this equation star, we get A1. Let's work on this. This is easier. So 1.005, 1.005 times A0, which is 100,000, minus P. Okay, this is A1. Now let's take n equals 1 here, then this becomes A2. That is 1.005 of A1, which happens to be this found in the previous line, which is 1.005 times 100,000 minus P. That's A1 minus P. Okay, we are basically plugging in n equals 1 here. And if we simplify, that means basically distribute this here, and we get A2 equals 1.005 quantity square times 100,000, that's A0, minus 1.005 P, and minus P outside. Okay, if we take n equals 2 here, then we get A3. A3 is 1.005 A2, 1.005 A2, which is here, we just found in the previous line, A2 minus P. Let's plug in A2 from this line, then we get A3 equals, this is A2, so we need to distribute 1.005 into A2. So basically we have 3 terms. Multiply by this, we get 1.005 cubed times 100,000. Okay, let me go up, minus we are multiplying by 1.005 to this, so 1.005 square P. Okay, minus, because 1.005 A2, so 1.005 P and minus P. Okay, that's A3. Now you may have seen the pattern now. Okay, you might know now. Look at here. A1 is 1.005 times 1000 minus P. A2 is now 1.005 squared times 1000 minus 1005, that raised to 1 P minus P. And this is A3. Then A4 would be 1.005 fourth times 1000, 1.005 third P minus 1.005 squared P, etc. Okay, or you can, if you like, you can write. So in this way, if we continue, A360, because we know the value, we know the balance after 360 payment, that would be 0. So that's why I want to find A sub 360. That will be 1.005 raised to 33, so 360. A naught, which is 100,000, minus 1 less, so 1.005 360, so 359. Okay, P minus 358P, etc. all the way to, we'll have this 1.005P minus P. Okay, and we know this balance after 360, that's 0, because we want the loan be paid up. So 0 equals this. And look, except the first, every single term has P. So we can factor P out. So this is 1.005 raised to 360 times 100,000. In fact, we can use calculator and just simplify this. Minus, from these 360 terms, by the way, 359 terms, we can factor P out. That leaves 1.005 raised to 359 minus the second term would be 1.005, 1 less 358, minus all the way to minus 1. Oh, minus is out, then this is plus 1.005 raised to 1, and eventually plus, this is also out 1. Okay, so we have a geometric series here. Look, 1, if you multiply 1 by 1.005, you get 1.005, 1.005 squared, 1.005 cubed, fourth, fifth, all the way to 359. Okay, and we can find the sum of this geometric series. So let me write that here. Let's look at this geometric series. When we have A plus AR, where A is the first term and R is the common ratio. If you divide second term by first term, you get R, or if you divide third term by second term, you get R. And when we have n terms, so basically here R raised to 0 all the way to n minus 1, then the sum is AR raised to n minus A over R minus 1. R is the common ratio, A is the first term. So in this geometric series, we have A equals 1 and R equals, just divide second term by first, 1.005. Okay, now using this geometric sum, series sum, we can find this sum, and let's find that. So 0 equals 1.005 raised to 360 times 100,000 minus P times, this sum is now A, which is 1, first term is 1, so we don't care about that, R raised to n, so 1.005 raised to n. Look, n minus 1, it becomes 1 more, so 359, this becomes 360, 1 more, minus A is 1, all over R minus 1, R is 1.005 minus 1. So basically this is a number. Okay, we can now solve for P. So move this, subtract this from both sides, basically moving this over, and divide by this number. Okay, so let me erase this now and use your calculator. So this is a decimal number, by the way. This is a decimal number, this is another decimal number. So P equals this over this. So P equals, move this to the left means subtract this number, so we get negative, and we are dividing by this negative, so that becomes positive. So 1.005 raised to 360 times 100,000 divided by this 1.005 raised to 360 minus 1 all over, by the way that goes on the top, all over 1.005 minus 1, just 0.005. okay, and use your calculator. Okay, and that gives you 599.56. so 599.56. Your parents need to make $599.56 of monthly payment. Okay, so thus the payments will be P equals 599.56, and if you want to write down the model, so AN plus 1 equals 1.005 AN minus P, which is 599.56. okay, final